equal that.
So this last example in 7.3, we're going to be looking at using our graphing calculator. So we're going to be solving this equation here, and the domain is 0 to 2 pi. So the first thing you want to do is head into your window and set your domain at 0 to 2 pi. And since we're using the constant 3, we definitely want that included in our range. So I have mine at -1 to 10. You could go 0 to 5. It really won't matter as long as you can see that 3, that horizontal line graphed on your screen. One side of the equation, the left-hand side, or right, it doesn't matter, is going to be your y1, and your right-hand side is going to be your y2. So we're solving equation really by looking at points of intersection. And this was like the problem we did on the last test. I want to know where do those two equations have equal value, and those are going to be at those 3 points of intersection here. So you're going to use the intersection feature of your calculator, and you're going to head over to second trace. And once you click second trace, you'll see number 5 is the intersect feature. And if you click on that, you'll have to repeat this 3 times in order to get all 3 points of intersection. Just keep in mind that when you get to the guess stage of the process, your calculator is going to go to the closest point of intersection. So if you started by solving this point here, and you got a value, and then you wanted to solve for the next point maybe over here, when you get to that guess stage, you're literally going to move your cursor by using the left-hand arrow. You're going to move that over to the point of intersection that you want to solve for. So just to make sure that you're using your calculator correctly, so you want to make sure, oops, I don't know what I did. You want to make sure that you are in radians. So your first point of intersection, well, one of them is 3.177. You're going to repeat that process for the second point of intersection. One of them is at 0.519, and then one more time for that third point of intersection, and you should get 5.710. So those are the 3 values of x that make this equation true. And you'll know that you can't possibly do this algebraically because this is made up of both a trig and linear function, and they just don't play well together when finding exact values. So I hope this helped, and yeah, enjoy the rest of your snow day.